Welcome back. I'm trying to set the time so that I don't go beyond, one video. I think miscellaneous questions number 4 or number 3. No, number 4. Number 3 or 2 has gone almost to 28 minutes. So I need to be careful. Well, I couldn't stop halfway on a particular question. That was the problem. So let us do, last lesson I did parametric equations. This lesson I'm going to do some mixed questions on implicit differentiation. Alright, remember when you differentiate a function of y with respect to x, you differentiate as it is and multiply by dy by dx. Of course, you still use the product rule and the quotient rule and the chain rule, whatever it is. So let's look at the first question, number 11. Find the points on the curve or point on the curve 3x squared plus 2xy plus 3y squared equal to 8, where the gradient is minus 1. Remember, if x is known, find y. If y is known, find x. If otherwise, look for any information to find x and y. So they want you to find the point, that means x and y. The information given is gradient is 1. But what is gradient? Dy by dx. The question is not y equal to, so please do not write dy by dx equal to. Don't write it, because then you will be wrong. So I will say, I told you either you write differentiate with respect to x or you write like this. If you write like this, you are showing that you are differentiating with respect to x. So 3x squared gives you 6x. This is uv. U is 2x. Y gives you dy by dx. Plus v is y. 2x gives you 2. 3y squared gives you 6y. But y gives you dy by dx equal to 0. Now again, don't try to look. Normally what students will do, find dy by dx equal to, and then put dy by dx equal to minus 1, cross multiply, simplify. But you can make your life easier and avoid unnecessary errors by using the value. But you know dy by dx is minus 1. Put minus 1, I get 6x minus 2x plus 2y minus 6y equals 0. So 4x equal to minus is equal to 4y or y equal to x. You understand that? I'm not saying dy by dx is 0. I'm putting dy by dx here, but when you differentiate 8, you get 0. So from there, I got a link between y and x. So put x equal to y, what will it become? 3x squared plus 2x times x plus 3 times x squared equals 8. 3 plus 2, 5 plus 3, 8x squared equal to 8, x squared equal to 1. So x equal to 1, x equal to minus 1. The question you have to look at is where x is 1, y is 1, x is minus 1, y is minus 1. So those are the points. That's why I put an S in the brackets, so that you know if there could be more than 1 point. Yeah. Okay. The next question is number 11. Number 12 rather. The equation of the tangent at the point 1, 2 on the curve x squared y cube equals 8. Well, as usual, tangent, so d by dx of x squared y cube equals d by dx of 8. So x squared gives you 2x, u times 3y cube gives you 3y squared dy by dx plus v is y cube, x squared gives you 2x equals 0. Again, as I told you, put x equal to 1, y equal to 2. 1 times 3 times 4 dy by dx plus 8 times 2 times 1 is 0. So dy by dx equal to minus 16 over 12, which is minus 4 over 3. Am I correct? Okay. 1, 3, y squared is 4, y cube is 8, x is 1, 4 3s are 12, 8 2s are 16. Okay. So y minus 2 is minus 4 over 3 times x minus 1. 3y minus x is minus 4x plus 4. So 4x plus 3y minus 10 equal to 0 is the tangent on that curve. Yeah? Same rule. You have to be careful about differentiation. Let's look at number 13. Find the equation of the normal at the point x equal to 3, y equal to 1 on the curve. So what's the curve? xy times x minus y equals 6. And you are being given x equal to 3, y equal to 1. So the point is 3, 1. Very good. There are two ways of doing it. Look, I have to use product rule, but there are three terms. So Uvw product rule is going to be a bit of a problem. So safer would be, can I say x squared y minus xy squared equals 6. Now I only have two terms. I can differentiate. So d by dx of x squared y minus xy squared equals d by dx of 6. That gives you uv. U is x squared. Y gives you dy by dx. Plus v is y. X squared gives you 1 minus u is x. When you differentiate y squared, I get 2y, but multiplied by dy by dx. V is y squared, x gives you 1. Here I went wrong. You say x squared gives you 2x. Idiot. And that should be equal to 0. So I get, for part A, look, if it was only that bit, I wouldn't bother. But I have something else there. So I need to find dy by dx. So let's find dy by dx. So x squared dy by dx minus 2xy dy by dx minus y squared plus 2xy equals 0. So dy by dx times x squared minus 2xy equal to y squared minus 2xy. Okay, now if I want to, I'll put x equal to 3, y equal to 1. So dy by dx times 3 squared is 9 minus 6 equal to 1 minus 2 times 3 times 1. So 3 dy by dx is equal to, now I'm a bit concerned, am I correct? X squared dy by dx plus 2xy minus x times 2y dy by dx, y squared times 1. So x squared dy by dx minus 2xy dy by dx minus y squared plus 2xy equals 0. So dy by dx times x squared minus 2xy equals y squared minus 2xy. That's perfectly alright. So 3 squared is 9, 2 times 3 is 6, 1 squared is 1, 2 times 3 is 6. So is minus 5. So dy by dx equals minus 5 over 3. So m for normal is 3 over 5. So what will be the normal? Y minus 1 is 3 over 5 times x minus 3. 5y minus 5 is 3x minus 9. So 3x minus 5y minus 4 is 0 is the normal. Alright? Remember, I cross-check twice because at times I'm now just teaching you. I can get away with silly errors because I'm not sitting an exam and I can always correct. Or I'll tell you, look, generally I do commit errors, you can figure out. But you can't afford to do that because you're sitting an exam. So you need to be a bit more careful. Not that I shouldn't be doing it, having done math for 50 years. But you know, I am in 2 weeks or 3 weeks, 2 weeks I think, I'm going to be 73 years old. So, bit of added brain, yeah. But it hasn't affected my knowledge of maths, but some silly errors creeping. Alright? Now, I have to now show further that there are no points on the curve where the tangent is parallel to y-axis. Look, if a tangent is parallel to y-axis, the angle made by the tangent is 90 degrees. Remember, gradient is the tangent of the angle made by the line with the x-axis. So it makes 90 degrees with the x-axis. So tan 90 is infinity. In other words, if a tangent is parallel to y-axis, dy by dx should tend to infinity. So let me just rub this off. I don't need this. I just need dy by dx. So in other words, tangent parallel to y-axis means dy by dx should tend to infinity. When does something tend to infinity? Which means denominator of dy by dx must be 0. What's dy by dx? Is y squared minus 2xy over x squared minus 2xy. So x squared minus 2xy equal to 0. X times x minus 2y equal to 0. X cannot be 0. You know why? Because we put x as 0, 0, 0, 0, 0 equal to 6 is not possible. So x cannot be 0. So therefore, x equal to 2y. I must show this equation x equal to 2y does not satisfy the given equation, because if there is no point, it should not satisfy. So what's the equation? xy times x minus y equals 6. So 2y times y times 2y minus y equals 6. Oops. I thought there was no value. I think I need to change the question. Where is the tangent? Find further. I think would be better. Find further points on the curve. Okay. So 2y squared times y squared equal to 6. Correct? No, times y equals 6. So y cube equal to 3. Y is equal to 3 power 1/3. X equal to 2 times 3 power 1/3. So the point is 2 times 3 power 1/3 comma 3 power 1/3. Remember, I make up these questions. So at times I could come across a dumb result. Hope you don't mind. That's why I had to change the question. Find further that, of course, don't worry, in your exam, they will have worked out and then they will given you the correct question. Okay. 2y squared times y, 2y cube is 6. Yeah, it works. Sorry, I had to change it. The last question I put there as a teaser, because whenever I did differentiation, especially exponentials, when I gave this question, find dy by dx, when y equal to e power x over e power 2x times e power 3x. Somehow students dread the letter e. E is just a constant like a power x, 2 power x, 3 power x. So what normally I saw would be generally they would use u over v, use product rule, and v squared, v du by dx, u dv by dx. No! Or some of the cleverer ones would do e power x over e power 5x. If you write that, I would have expected some of them to realize that can be simplified, but they didn't. They still use u over v. No need, you see, because this is e power x over e power 5x, which is e power minus 4x. So dy by dx, e power minus 4x is e power minus 4x. That's a minus 4. Simple. But in the exam, you don't think that clearly. Ooh, that's given. There are two terms, so at least I can combine them. And having come here, very few realize this. Majority did u over v. V is e power 5x, and ultimately they came with the same answer. But there was no need. Right. So I have spent considerable time going over various aspects of differentiation. I've given you wherever possible the notes. The only place where I didn't give notes was the rates of change and small changes. I think I have a question on small changes. So I'll just do that. Question number 15. I will just write it here, do it, and that will finish this particular lesson where I was going over various concepts related to differentiation. Okay? The volume of a sphere is increased by 3%. Find an approximate increase, percentage increase or percent increase in part 1, the radius, part 2, the surface area. Remember, we use dv by dy by dx is approximately delta y by delta x. Yeah? Because for small values, where delta y is the change in y, delta x is the change in x. Now, what's the volume of a sphere? V is 4 over 3 pi r cube, and delta V is 3% of V, that is 0.03 V. What is delta R? So what is dV by dr? dV by dr is 4 pi r squared. So delta V by delta R is approximately 4 pi r squared. I need delta R. So delta R is approximately delta V over 4 pi r squared, which is 0.03 V over 4 pi r squared. But what is V? 0.03 times 4 over 3 pi r cube over 4 pi r squared. So that is, look, the 3 and 0.03 gives you 0.01. 4 pi and 4 pi will cancel, 0.01 r, so 1% increase. So if the volume increases by 3%, then the radius will increase by 1%. Yeah? Very good. So I know now this is 0.01 r. See, that's the reason there's a hint. They didn't ask for surface area first, They ask for radius first because you need the percentage increase in radius to find the percentage increase in surface area. So what is surface area of a sphere? Surface area is 4 pi r squared. So dA by dr is 8 pi r. So delta A by delta R is approximately 8 pi r. So delta A is equal to 8 pi r delta R. What would that be? 8 pi r times delta R is 0.01 r. So it is 0.08 pi r squared. What is the percentage? Is delta A over A times 100. That is 0.08 pi r squared divided by 4 pi r squared times 100, which is 2%. In fact, I remember way back in, of course, I think your dad must have been born that time. Way back in 1983, I think, in one of the Cambridge papers, they had asked, show that if the radius of a sphere increases by 1%, the corresponding increases in the surface area and volume are 2% and 3% respectively. That was the question, I remember. Suddenly now I realize, yeah. So that is how you use small changes. As I said, small changes, I have not come across this in the Excel syllabus. Well, anyway, I am going to do next. First, I'll do logarithmic differentiation. I want to do it as a separate unit because it's not a standard method in the sense that it's not something which many of us teachers teach at A level, but I find it very useful, especially in complicated questions when you ask to find dy by dx. And after that, I'll spend some time teaching you derivatives of inverse trig functions. I think this is mainly for people doing OCR and then AQA, people of the from those syllabi. I think they have it. At Excel, at the beginning, they introduced inverse trig functions derivatives. Later on, they removed it. I don't know today because, the last time I taught A-level maths was 2020 or 2019. No. Yeah, 2019. I did teach a bit of further maths, but not maths at A-level, pure maths. So I do not know whether they have brought it back. If they have brought it back, you have it. If they haven't brought it back, you can ignore that particular video or videos, or if you want to, you just listen to them. Knowledge doesn't go a waste anywhere. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.